In this lesson, we'll be using the identity cos A minus B is equal to cos A cos B plus sin A sin B to prove that sin A minus B is equal to sin A cos B minus cos A sin B. So remember what I've said, that when we are dealing with sign, the sign that is inside the bracket is the same as the sign that is on the outside. And I'm going to copy the same strategy which I have used in the previous lesson to tackle this one. So I want cos A minus B, and I know that cos A minus B is equivalent to the sine of, let me do it the other way around. I know that the sine of A minus B is the same as the cosine of 90 minus A minus B. So that's what we must know. It's a cofunction. The sine of A minus B is equal to the cosine of 90 minus A minus B. So we said we can take this thing as theta, and we can take this again as theta. So we can say that the sine theta is equal to cos 90 minus theta. We have said it in the video for cofunctions, so make sure you visit the lesson for cofunctions. So that's what we're going to do. We're going to say that sine A minus B is equal to cos 90 minus A minus B. And again we can say that cos 90 minus A minus B is equal to the cosine of 90. We distribute the minus to the to the brackets. 90 minus A, and then negative times negative B is plus B. Just as we have done in the previous lesson, we're going to isolate the 90 minus A from the positive B. And at the end, what we must note here is that sin 90 minus B is equal to cos 90 minus A minus B, and cos 90 minus A minus B is equal to cos 90 minus A plus B. So what can we say? I've given an example that we can take it in this way. We can take it as A is equal to C and C is equal to B. So what does this mean? Because A and B are both equal to C, we can therefore say that, okay, therefore B is equal to A. What is the reason? The reason is that they are both equal to C. So I hope it is clear. So we're going to use the same procedure here. We're going to say, here we have cosine, then 90 minus A, then plus B. I don't think I'll have enough space. Let me try to squeeze them. So I'm going to say that it's cos 90 minus A and then plus B. That is equal to, remember, this identity is for cos. So what did we say about cos? We said that cos A minus B is equal to cos A cos B plus sin A sin B. So we can take 90 minus A as our A and B as B. It's fine. So this means that cos 90 minus, this time it's cos 90 plus. Remember, we have the identity for cos 90 plus, but it says that cos A plus B is equal to cos A cos B minus sin A sin B. So we're going to do the same thing. We're going to say that cos 90 minus A plus B is equal to, here it will be cosine of 90 minus A. We take it as one thing, that's why we've placed it inside the brackets, and then followed by cos B. And remember, with cos we said the sign that is here is different from the sign that we're going to put on the outside. This means that on the outside we're going to have negative. Why? Because we've got positive on the inner side. So this side we're going to have the sign of, 90 minus A then multiplied by the sine of b, and this is it. Then let's see, what did we say about the left side? What did we say about this? We said it's equal to sine a minus b. So where we see it, we can replace it with sine of a minus b. So you are going to have sine a minus b, then it's equal to, what is cos 90 minus a? It's a cofunction, remember? So we can say that cos 90 minus a is equivalent to sine a. So here we're going to have sine a, and then cos b minus sine 90 minus a is equivalent to cos a sine b. So this is the identity. We have proved it. So make sure you follow all the steps which are needed to prove the formulas. So we use the original one, doesn't need to be proved. Cos a minus b is equal to cos a cos b plus sine a sine b. We don't prove it, but we must use it to prove the remaining of the three. So I'm going to write them here. So the original one is given as cosine of a minus b is equal to cos a cos b plus sine a sine b. So this is the major one, or rather the original one, but we use this one to prove the remaining three. We have to use the black one to prove that cos a plus b is equal to cos a cos b, then minus sine a sine b, and that is the first proof. So remember, with cos, the signs are different. The sign that is here and the sign that is here are opposite. So if inside the bracket we've got negative, on the outside we'll have positive. And again, we can prove this one, that sine a plus b is equal to sine a cos b. Then with sine, the sign doesn't change, plus cos a sine b, and the last one is given as sine a minus b is equal to sine a cos b minus cos a sine b. So this is proof 1. Proof 2 and proof 3. So make sure you watch all the lessons on how to prove them. We must be able to transform the black one to give us the 3 green ones. So these are called compound angles. So even if they are given in trigonometric expressions, you must be able to evaluate them and use them. So we've got 4 compound angles, and this marks the end for the lessons for compound angles identities.